So the dendrites are where the receiving neuron receives the messages from the sending neuron. The cell body is where most of its organelles lie. The hillock body is where the axon and the cell body connect. The axon is where the action potential is sent down. The myelin sheath is basically something that insulates the axon and makes the messages go through the axon quicker. The axon terminals are the end of the axon where where the last place where the messages pass through before they go over the synapse, which is the gap between the sending neuron and the receiving neuron.
The neuron is a nightclub, and the channel proteins act as bouncers. At around 12, the bouncers start letting in sodium, also known as females, who at a certain threshold population within the neuron start calling their friends, causing the bouncers to let in more females into the club. At this point, the club is packed. The potassium males and the sodium females are mixing within the club, and the neuron is depolarized. It's about 2 a.m., and the club is so electric, it's 30 millivolts. But now, the club is so full, the bouncers have to finally start kicking out all the potassium males and repolarize the neuron. However, they do their job just a little too well, and the charge inside the neuron is about negative 80 millivolts. So at 5 a.m., the bouncers just give up and activate the ATP-powered turnstile to kick out 3 girl sodiums for every 2 male potassiums brought back into the club, bringing the neuron back to a resting potential of negative 70 millivolts.
We begin with the neuron at resting potential at negative 70 millivolts. As time passes, the neuron reaches the threshold, and then at 2 a.m., it reaches the action potential at positive 30 millivolts. And then, in a process called repolarization, the neuron is put below resting potential, below threshold, at negative 80 millivolts. And then at around 5 a.m., it returns to negative 70 millivolts, back to resting potential.
The neurotransmitter passes through the axon and reaches the terminal branches. These transmitters can either be inhibitory, which doesn't stimulate activity, or excitatory, which does stimulate brain activity. These transmitters, once they reach the end of the branch through synaptic vesicles, they fuse with the end of the branch, just like exocytosis, and they are released into the synaptic cleft. The neurotransmitters are then received by the postsynaptic membrane.